Hello friends, this video on Haloalkanes and Haloarenes part 31 is brought to you by examfear.com. No more fear from exam. We'll take some numericals here. The question is, which one is more likely to go for SN2 faster? So SN2, I told, both are involved. There is attack by nucleophile. The nucleophile has to be strong, it attacks. And to attack, there should be no steric hindrance. So if you see in this, there is a steric hindrance. So you draw the structure, this is Br, then I have CH3 here, then I have H here, then I have C2H5 here. Steric hindrance. Draw this structure, if you see this, I have some big compound here, but I have H here, I have H here and Br. So the steric hindrance is less, right? It's 1 degree. This is 2 degree. So this is more prone to SN2 reaction because there is no steric hindrance. Which one would go more rapidly by SN2? Again, same thing here. So here if you see, this is more steric hindrance here, right? 1, 2, 3 methyl groups. Here if you see, the steric hindrance is less, right? Because this is 2 degree and this is 3 degree. So obviously this is more likely to go for SN2. Correct. Again, a similar question. So here, which one is more likely to go for SN2? Here also, if you see, if we talk about a steric hindrance, this has more steric hindrance. Why? So if you see, draw this compound, this is H, and this compound which I have got, again here has CH3. Right, this compound here is also branched. It's very soon it's getting branched. Here if you see, this is Br here. This is my Br. This is H2H. But if you see this compound, I have CH2, I have C, then I have CH3, then I have CH3 here. So if you see, this branching is, this is more space is there. Here the space is less, right? So this is more sterically hindered. So this is the one which can go for SN2 easily. So the question is, which one will go for SN2 faster? Sorry, SN1 faster. So SN1 I told, if it is 3 degree, it's good because we form carbocation. Because SN1 depends totally on leaving group, right? Leaving group and forms carbocation. So this is 3 degree, this is 1 degree, sorry, this is 3 degree, and this is 1 degree. So 3 degree is favored for SN1 reaction because the stability of carbocation that will be formed is more stable, right? So the next question is, we have to again find which one will go for SN1. SN1 again I told, this is 2 degree, this carbon is 2 degree, this carbon is 1 degree, right? And this will gives a stable carbocation. Stable carbocation, if you see, this is what I'll get, carbocation. In this case, the carbocation I will get is this. This is 1 degree, this is 2 degree. It's more stable carbocation, so this will go for SN1. Let's identify these compounds A, B, C, D, E, R, R1, the following. Right? So let's see this. This is a haloalkane. It reacts with a magnesium, so we will get an organometallic compound. We have seen that RMgX. So this is Rx with Mg. We have seen this compound. Rx reacts with Mg. We'll get RMgX. So A will be what? A will be RMgX. So let me draw this A here as RMgX. Or let me write it here. A is, this is my R here, and Mg, and X is Br. This is my A. This is done. Let's see for B. B, you are saying you react with water. We have seen that the moment it reacts with water, what will happen is you take Rx, RMgX, you react with water, you get RH plus Mg OHX. You have seen this reaction. So this will become RH, that means this with the H, That means B will become, replace whole MgX with a H, and H is nothing but nothing. I mean, everywhere we have H. This is my B. So I'm done with B. Now we have RBr plus Mg in place of dry ether. Again, we'll get RMgX kind of thing. So here we'll get RMgBr. Here we'll get RMgBr. So let me write C as RMgBr. C is also done. Correct. Now RMgBr, when it reacts with D2O, it gives this compound CH3, CH, CH3 and D. Right? So what is R? So with this, if we compare these, we can say that R is nothing but CH3 is R MgX, right? So it's R is CH3. See, if it gives D here, as I told that RMgX will react with water, it gives RH plus MgOH. So RMgX when it reacts with D2O, it will give you RD plus MgOH ODX. To be read clearly, RMgX when reacts with D2O, it should give RD plus MgODX. Correct? So this is RD. This is RD here. That means the compound which I have is nothing but CH3, CH, CH3 and MgX. Correct? Because MgX will be replaced with D. Correct? This is my total C. So C is actually this. C is nothing but this compound. CH3, CH, CH3 and MgX. So if you compare C is RMgBr also in this, that means this is my R. Correct? So my R is this. Where is my R? Yeah, I found R, I found A, B, C and D. Correct till now? Oh, D is something which I have not yet found. I'm assuming D and I have not yet found D. I'll find it later. But I think this D is different. This is just a D2O, the heavy water. This is heavy water. Correct. Now I will see this. So I had some compound R1X. When I added Na ether, right? This is my Woods fatigue reaction. I got this. When I added Mg, I got this, and when I added water, I got this. So if you see this is fatigue reaction R1X, that means my R1 is something like this, half of this. Correct? So my R1 is this compound is nothing but this. This is my compound R1X. So R1 is this without X, right? This alkyl. So I got R1 also. Now when R1X will react with Mg, it will form RMgX. That means it will form something like this. Correct? And this is nothing but my D. So I got D also. Now when this D reacts with water, I get E. So if you react this with water, what you will get? Your MgS will be replaced with hydrogen. So it will become CH3, C, CH3, CH3 and H. Correct? So this is my E. This is my D. Correct? So I found all the compounds. I found A, B, C, D and E. Pretty easy. Let's take one more example. C5H10 does not react with chlorine in dark but gives a single monochloride compound C5H9Cl in bright sunlight. We have to identify the hydrocarbon. The question says that C5H10 plus Cl in the dark, no reaction, and C5H10 chlorine in the presence of sunlight, it gives C5H9Cl, and only one monochloro compound. Monochloro. See, now if you see C5S10, if you see the formula, says if you see the alkane is CnH2n plus 2. So you put n is equal to 5, it has to be 12. But it is not alkane, it is 10. That means it is alkene or cycloalkane, correct? Because there is a double bond or it is a cyclic in nature. So this assumption we have got as C5H10 is either alkene with a single double bond or it is cycloalkane. We don't know. No, but it says it doesn't react with chlorine in dark. So in chlorine in dark we have an addition reaction, but it doesn't react with chlorine. That means there is no double bond. That means it is not alkene. It has to be alkane. So now alkane, if you say cycloalkane, for C5 you can have one is this, one you can have 4, and then you can have methyl group here, or you can have 3 with ethyl group. So the 5 possible options for this C5S10. Now it says that when you add a chlorine, one chlorine, it gives only one monochloride compound. So in this, if you add a chlorine, it will give you one monochloride compound, because you can add chlorine here, 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 doesn't matter. In this, if you add, you can get compound 1 if you add here, 1 if you add here, 1 if you add here, and 1 if you add here, right? 4 chloro compounds in there. In this, if you add, you get 1 here, 2, 3, and 4. Here also you'll get 4 monochloride compounds, right? But it says that it's only one monochloride compound. That means these two possible are not a feasible option. This is the feasible option. That means the compound I'm talking about is cyclopentane. Hope you understood the two logic. The first one with the formula, we could found that it's either alkene or cycloalkane. The first clue was given that in the dark it doesn't react with chlorine. That means it is not alkene. It has to be cycloalkene. There are 3 possibilities of cycloalkene. The next clue we have got was that when it reacts with this guy, chlorine in sunlight, it gives one monochloride compound, and we saw that only one of these, that is cyclopentane, is meeting this condition. Now the question is, which one of these will react faster with SN2? So for SN2, we know that factor that matters is strong nucleophile, right? SN2 less steric hindrance and good leaving group, correct? These are the few important criteria for SN2 reaction. So if you don't know all these things, watch my previous videos where I explained why SN2 requires all these things. Now let's see this compound CH3Br and CH3I when it reacts with OH minus. Nucleophile is same, so we can't do much about this. Steric hindrance is same in both cases, we can't do much about this. But the leaving group is different, right? So we have here iodine as a leaving group, here bromine as a leaving group. We know that the leaving group priority I minus is better, then Br minus, then Cl minus, then F minus. So iodine is the best leaving group. Why? Because iodine is bigger in size actually. Chlorine, chlorine, bromine, iodine. Iodine is bigger in size. As you go down, iodine is bigger in size. So it is easy to break Ci bond. It's a better leaving group. So if you compare these two, this will be a faster reaction. Correct? This is done. Let's take part 2. Part 2, I have CH3 here, CH3 here, CH3 here, Cl, this is one compound, and I have CH3Cl. So let's again see. Nucleophile, in both cases I have same nucleophile, it doesn't matter. Steric hindrance, this has more steric hindrance, this has less steric hindrance. So I am looking for less steric hindrance. So this will be faster SN2. Correct? Because easy to attack, nucleophile can easily attack. Nucleophile will not be able to attack here. So SN2 is faster here, but SN1 will be faster in this case. In this case, this will be fast SN1, because if you see, it forms a stable carbocation. Correct? This will be faster SN1 and this will be faster SN2 reaction. Predict all the alkenes that would be formed by dehydrohalogenation of following halides with sodium ethoxide and ethanol, and identify the major product. So I have 1 bromo, 1 methyl cyclohexane. So let me draw the structure. Let me draw bromine here and CH3. The cyclohexane at one position I have a bromine and methyl. Now saying that sodium ethoxide 3,2H5ONA, that is, this is a very strong base. Ethanol solution C2H5OH, that is, it is protic solvent. So it is protic solvent. Protic solvent means it is either my SN1 or even. Correct? These two are possibility. Now it talks about dehydrohalogenation, that is, I am talking about even reaction. So in this case, this is my alpha carbon and I have 2 beta carbon. But both are same, it doesn't matter because both symmetrical, right? So if you draw in this case, if you try to do a dehydrohalogenation, it will be this one, H, because this C2H5O minus will attack any of these hydrogen, right? So it will attack this hydrogen because it's a base. It will attack this hydrogen. This bond will break. This will become a negative charge, and then this will push this Br minus here. This bond will break. This is positive charge. Positive and negative will form a bond here. Correct? So this bond will break. This will be positive. This negative. Positive will go with hydrogen. This will be a negative charge. This bond will break, and this will be negative and positive. This positive and negative will form a bond. Correct? Again, we have to find all the alkene that will be formed by, again, dehydrohalogenation of 2-chloro-2-methyl-butane. So let's see this. Let's form this butane first, methylprobute. At second I have chloro. At second I have methyl. And this is I have. Again, same thing. C2H5ONA. Right? Methoxide ion, and in the presence of C2H5OH, protic solvent, so it will be even reaction. Correct? Now what will happen is this guy, this is my alpha carbon and there are 2 beta carbon here. Correct? Now this methoxide or ethoxide can attack this beta carbon or it can attack this beta carbon. What it will do? So based on the rule we have studied, the base will attack the carbon with lower number of hydrogen. Correct? So it will give a more tail product. So it will attack this. This is a major. This will be my major one, and this will be my minor. So in this case, I'll get 2 product. So the major one will be in this case, that is CH3, C double bond C, CH3, CH3. This is my major product. And the minor will be attacking this hydrogen. It will be CH2. There will be a double bond here. C, CH2, CH3, and there is a CH3 over here. This is the minor product. Correct? So this is what we'll get. We'll get 2 products, one major and one minor. Let's take the same question for different substrate. 2,2,2,2,3 trimethyl bromopentane. Let me first find pentane with propupent. At 2 I have 2 methyls. At 3 I also have a methyl. And 3 I also have bromo. This is my compound. Right? I can add hydrogens here. CH3, 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 this is tetravalent combined, this is CH2 and this is CH3. This is my alpha carbon, the carbon with the star. So I have 2 beta carbons here. This is beta carbon. In fact, this is 1 beta carbon. And in fact, this is 1 beta carbon. Right? There are 3 beta carbons here. One is this beta carbon, one is this beta carbon, one is, oh, there is no beta carbon here because there is no hydrogen here actually. This is not beta carbon, there is no hydrogen to attack. There are two beta carbons here. So as per the rule, this has less hydrogen, so it will be a major product. This will be a major one, and the other, this guy will be a minor one. Correct? We'll do a dehydrohalogenation, again even reaction. Why? Because this is ethoxide ion, C2H5O minus is my ethoxide, and then my ethanol is a protic, so it will be even reaction. So again we'll subtract, we'll do a dehydrohalogenation. So two products I'll get. The first, the major, where I'll remove this hydrogen and this bromine from here. So I'll get CH3, C with 2C here, and 1C, one double bond. This guy here also I'm gonna have C here. Correct? And this is again CH3. This is one product I'll get. There will be H here. CH3, CH3, CH3. This is one major product I'll get, and one minor product I'll get where I'll remove hydrogen from this carbon. So let's see, this is CH3, C, CH3, this I can just keep it intact. This is a carbon. From this I'll remove halogen, and from this I'll remove one hydrogen, and this I'll keep intact. Right? This will be a minor product. Why? Because I'm removing here from this carbon. Right? I'll put a star here. I'll put a star. This carbon.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.